Okay, so hello fellow geology buffs, this is Glenn, and today we're looking at, well, I've actually posted this before, but it's something new. As you can see, there is pretty much a cave-in. This is pretty recent, and as you can see, this is why you need to be careful when you go to cliff faces, because this thing can happen, and it can happen at any time. Now, why is this happening? Well, basically, you've got this unconsolidated sediment. So this is basically just gravels with silt. As you can see, it breaks apart quite easily. So this is unconsolidated, means that the pressure has not been bared down on it, and also temperature to actually compact it. It's just like, I don't know, a soil. Basically, this would have been deposited by a river, as you can see by the rounded pebbles that you can get in the actual material. So this is part of the problem, and on top of it you have, well, crystallized basalt. So there's lots of vesicles. So this is the first layer of a lava eruption that came down, and then you got subsequent layers. You can tell if it's got lots of vesicles, means it is pretty much cooled down at the top of the lava flow. It could have been reworked into the actual lava as the lava was going over it, but here we go. As you can see, the unconsolidated material gets eroded a lot quicker than the basalt. So the basalt is just crystals, very fine crystals. So this is basalt, and it's a mafic lava, so it has lots of it's silica deficient, so there's lots more magnesium on all those minerals. You can look at mafic lavas on Wikipedia. And so this red stuff is getting eroded. The basalt is staying there, but as you can see, the basalt's fractured. That probably would have happened during the cooling stage, as a liquid solidifies or cools down, it contracts. So that's what happened to this basalt. And as you can see, it's quite thick. So this is probably 100 meters thick up the top, and I'm not too sure of the thickness of this unconsolidated material. It seems to go down quite a way, and it does grade into a sedimentary rock. So as I'm walking along, you can see there's a lot of the actual basalts actually come down the side, and you can see the erosion that's happening with the water trickling down the side, and that might actually come from the aquifer in the basalt, because basalt water goes through the basalt quite quickly. In this unconsolidated, probably does go through quickly, but the pore space is actually quite small, so it's probably pretty slow. Okay, and here we had another rockfall previously, but if you could see, that's where the rockfall is. This is pretty much a contact between that yellow stuff there and the actual unconsolidated. So this is the Silurian sedimentary rock. Might be the Hume Vale or Dargole Formation, I'm not too sure in this locality, and that makes up all this rock. So this was laid down first about 380, 400 million years ago. Then it was pushed up by mountain building. It was cut by a stream, so this is all being removed and deposited. So this would have been a bank of, it could have been a lake, I'm not too sure. It could have been a stream bed, or it could have been a braided meander. I would say because there's lots of fine material, it's probably more likely a lake bottom, or probably an entrance to a lake bottom. So that has to be older than about 1 to 2 million years, because this basalt's about 1 to 2 million years old. So this is older, and that's basically what you need to look out for when you actually come out to sites like this, cliff faces. Anyway, hope this helps you with your videos. Just be careful out there. As you can see, this is actually grading down, so this has been eroded up the top. It looks like there's a paleosol in between the basalt and the unconsolidated material, so the unconsolidated materials turned into a soil. Anyway, thank you very much. Have an awesome geological time.